A quick overview of everything we've discussed so far. A function is a rule that associates every element in a set called the domain with exactly one element in a set called the range. So we could have equations, and we've seen this example, f of x equals 2x plus 1, we proved is a function, because if I plug in an x, any number, I can double it and then add 1, and I'd still get a valid answer, and I'll get exactly one answer. So that's a way of showing that for every x, I get exactly one y. Now, we also graphed this function, and I'm just going to sketch a rough graph. So we have f of x equals 2x plus 1. This, let's say, is the graph of that function. Then we said that another way of doing this graphically is we plug in an x, get a value for y, and make sure that for every x we're getting exactly one y. So this is how we evaluate functions. You plug in an x, draw a straight line to intersect with the graph of the line. So this perpendicular pink line intersects with the graph of the equation at exactly this dot, and then this is how we figure out the f of x. So when we plug in an x, we get an f of x. So for every x that we plug in, we get an f of x. Every x has exactly one y associated with it. So that's another way of proving that it's a function. And then we said, okay, so if that is how we decide whether a graph represents a function or not, and if we have this graph, how do we prove that it is the graph of a function? If every x must have exactly one y, that is the same as saying that if I draw vertical lines through this graph, and if every vertical line that I can imagine drawing through this graph intersects with the graph at exactly one point, that is the same as saying that every x has exactly one y. So this is called the vertical line test. Now let's see if we can use the vertical line test to show that the given graph is a function. Now suppose we have a graph like this. How do we know this is a function? Imagine drawing vertical lines through the graph. And then ask yourself, does every vertical line that you draw through the graph intersect with the graph at exactly one point? Every x, exactly one y. Every x, exactly one y. That's exactly what it means. So this is called the vertical line test. You cannot imagine a vertical line that'll intersect with this graph at more than one point, giving you a situation where x is associated with more than one y. That's not possible because of the vertical line test. So graphically, we've proved that using the vertical line test, we've proved that this is the graph of a function. Let's look at another example. Think of a circle with the center as the origin. Okay. Is this a function? Let's do the vertical line test and show that this fails the vertical line test. So we plug in an x. So the vertical line test tells us that there are two intersections of this vertical line with the same graph. So if we plug in an x, we get a y here and another y here. So this is not a function. So clearly this is not a function. Let's look at another example. Okay, so we have this equation. Let's say this graph, which we get from an equation, and let's check if this is a function. Let's do the vertical line test. If it's a graph, we can do the vertical line test. Imagine a vertical line through this graph. Does it intersect with the graph at more than one point? Even if one of the lines intersects with the graph at more than one point, then we can say that this is not a function. Okay, so if this is an x, this is f of x, and this is also f of x. That's what this vertical line test shows. If it intersects with the graph at more than one point, it's saying that an x is associated with more than one y, and that is not a function. Now, think of any straight line, no matter what it looks like, a negative slope, a positive slope, any straight line. Think of vertical lines going through the graph. Notice that it intersects with the graph at exactly one point and no more than one point. The vertical line test says that any straight line is a function. How about this? Do the vertical line test. Imagine vertical lines going through the graph. Does the vertical line intersect with the graph at no more than one point? So the answer is yes, no more than one point. So this is a function. If it intersects with the graph at more than one point, this one is a function. Any straight line is a function. Any vertical line intersects with the graph at no more than one point. This is a function. What was not a function was something like this. Intersects with the graph at more than one point. Even if one of the lines intersects with the graph at more than one point, then it is said to be a graph that is not a function. A circle with any center, not a function. Imagine lines through it. There are many lines that will intersect with the graph at more than one point. So this is how the vertical line test is used to determine if the graph represents a function or not. Now, let me draw some graphs. And let's say this is a parabola. First of all, think of the vertical line test. And it's clear that any vertical line drawn through the graph will intersect with the graph at exactly one point, no more than one point. Okay, so that passes the vertical line test, so we know this is a function. Now let's find the domain and range of the function. Remember that this graph goes on and on forever, which means for every x that I plug in, there is a y. Every x that I plug in, there is a y. Remember that this goes on forever. And no matter how far I extend it, if I plug in this x, I'm going to find a y, although this is not in the range, not in the window that we can see, but you can imagine that it's going to intersect with the graph at some point. So basically, the domain of this function is all possible x's. So the domain of this function is all real numbers. And let's say that is 1, 2, and 3. So what is the range of the function? It is all real numbers, all the y's basically. So if I plug in an x, I get a y. But no matter which x I plug in, the y will always be greater than 3, greater than or equal to 3. So the range of this function is all reals greater than or equal to 3. So the range is all y's and the domain is all x's. Now, if we look at the straight line, which goes on forever, I can plug in any x. So I'm looking at the domain. I can plug in any x into this function and get a corresponding y. No matter how far I go on the x-axis to the left and to the right, I'm able to draw a vertical line to intersect with the graph and then find a y. This tells me that the domain is all real numbers, no exceptions at all. And what's the range? All possible y's. So if I look at a y here, I know I'm going to find an x corresponding to it. If I look at a y further off and I know I can extend this graph, I can find an x corresponding to it. So the range is also all real numbers. Now suppose I have a graph. And my graph looks like this. There's a hole here and a dot there, and it continues that way forever. So think about it. Is this a function? The answer is yes. Every x has exactly one y. Notice if I draw a vertical line through this problem, through this point x, I know it intersects with the graph at this dot, which means I can find the value of y, exactly 1. So any line drawn through the graph intersects with the graph at exactly 1 point. This tells me that this is a function. What is the domain of the function? All reals. I can plug in any x into the function and find a value of y. So the domain is all real numbers. Now, what's the range of this function? Every x that I plug in is going to give me a y. So plug in an x, I get a y. But notice that I cannot go below this point. And this is a hole. So my range, that is all the possible y's, has to be greater than, strictly greater than whatever this number is. Let's say it's a 2. It's greater than 2. I cannot say equal to 2 because it's a hole and not a dot. So x has to be greater than 2. So the domain is all possible x's. I can plug in any x, but my range will not go below 2. It's all real numbers greater than 2. So this is all reals greater than, strictly greater than 2. It cannot equal 2. So that's the domain of the function. If you think about the interval, it is 2, positive infinity. This is negative infinity, positive infinity.